Okay, we're going to take Newton's final law, Newton's third law. You probably know it as for every action, there is an equal and opposite reaction. For our objective, it says to state that a force is an interaction between two objects and that both objects in the interaction experience an equal amount of force but in opposite directions. Identify interactive force pairs by using format A acts on B, so B acts on A. Explain why interacting force pairs are not the same as balanced forces, and explain why interactive force pairs can never cancel. So essentially what we're going to explore here is the concept of two objects interacting. So for example, we're going to take a look here at, this is going to be an epic drawing, a foot kicking a bowling ball, which is an intelligent thing to do. So we'll call the foot A, and we'll call the bowling ball B. So essentially what's going on here with these interacting force pairs is the foot, object A, kicks the bowling ball to the right, and according to Newton's third law, the bowling ball then kicks the foot to the left with equal and opposite force. So however much force this object puts on the bowling ball, let's say it's positive 40 newtons, then the bowling ball is going to apply the exact same amount of force but in the opposite direction. So negative 40 newtons. Now, here is the kicker. See what I did there? Kicker. Instead of a single object drawing maybe like a free body diagram of that object, we're talking about two completely independent objects. So instead of these objects and these forces being able to cancel each other out or to balance, we use the word balance, they can't do that because when we balance forces or we cancel forces, we are typically looking at the forces like F of N and F of G. Normal and gravitational, let's say in this particular case is just the eraser sitting on the table. F of N and F of G are equal, they are opposite, but they're only acting on a singular object, the eraser. If we are talking about the eraser and the table, these could not balance, these could not cancel. So when we're talking Newton's third law, when the ball kicks back on the foot kicks on the ball, equal and opposite forces, this balance is a no-no. And the fact that they could cancel is also a no-no. Since we are talking about two completely separate objects, they just happen to be interacting with each other. So when Newton's third law says for every action there is an equal and opposite reaction, they're always talking about at least two independent objects. So you cannot balance those forces, you cannot cancel those forces. Even though they are equal and opposite, they're involving two separate objects, completely unlike the scenario when you're talking about the forces acting on a singular object. So anytime, any scenario, you have two objects interacting, Newton discovered no matter what, whatever force was applied from one was applied right back from the other. That includes, like I explained in class, the bug on the windshield of the semi. As insane as that seems, when a bug flies into the windshield of the semi, the bug applies, say, 2 newtons of force on the windshield applies 2 newtons of force on the bug. They're equal, they're opposite, but they cannot balance and they cannot cancel because they're two completely separate objects.